Imagine you are holding a piece of rock, not a gemstone, not anything that glitters, just a flat, gray slab of shale, cool and smooth against your palm, no bigger than a paperback book. You might walk past it in a museum without a second glance, but look closer, because pressed into that stone, with a precision that almost doesn't seem real, is the outline of a creature. Legs, eyes, a mouth unlike anything alive today. And it has been waiting inside that rock for over 500 million years. This is not just a fossil. This is a message from a world so alien, so fundamentally different from our own, that scientists are still arguing about what they're even looking at. The Burgess Shale, discovered high in the Canadian Rockies in 1909, is one of the most extraordinary fossil sites ever found on Earth. And what it contains doesn't just rewrite the history of life. It raises questions we still cannot answer. To understand why that matters, we have to go back, way back, to a moment roughly 508 million years ago, during a period called the Cambrian explosion, a time when complex animal life didn't just appear, it erupted. In the span of a few tens of millions of years, the oceans filled with creatures of almost incomprehensible variety. Bodies with no blueprint, eyes with no precedent, mouths that evolution has never tried again. And then, in one extraordinary geological accident, a mudslide buried an entire community of them. Perfectly, instantly. And the Burgess Shale kept their secrets locked in stone, until we came along and started asking the wrong questions. The first creature we need to talk about should not exist. That's not a metaphor. When paleontologist Charles Walcott first pulled Hallucigenia sparsa from the rock in the early 20th century, he genuinely could not figure out which end was the head. He reconstructed it upside down. For decades, the scientific community accepted that reconstruction. It wasn't until 1991, nearly 80 years later, that researchers realized the entire animal had been flipped. What Walcott thought were legs were actually spines. What he thought were tentacles on its back were actually legs. Hallucigenia sparsa was roughly half a centimeter to around 3 centimeters long, smaller than your thumbnail in many cases. It walked on paired, stubby legs along the seafloor, protected by a row of sharp, mineralized spines along its back, and it had a throat lined with tiny teeth, a feature so unexpected that when researchers confirmed it in 2015, it made international headlines. Even its head took decades to identify. For a long time, scientists mistook a dark stain at one end, likely decayed fluid from the animal's body, for its face. This was not a simple animal. It was not primitive in the way we usually mean that word. It was fully formed, fully functional, and utterly unlike anything we had a category for. And if something this small, this strange, could confuse the world's leading experts for nearly a century, you have to wonder, what else are we getting wrong? Meet Opabinia regalis, 5 eyes, a flexible, hose-like proboscis extending from the front of its head, tipped with a claw. No living animal today shares its body plan. None. When a paleontologist first presented a reconstruction of Opabinia to the scientific community in 1972, the audience laughed. Not out of cruelty, out of pure disbelief. It looked like something a child had invented. It was approximately 4 to 7 centimeters long, swimming through Cambrian seas using a series of lateral lobes along its body, flap-like structures that may have functioned like fins, though researchers still debate exactly how it moved. Those 5 eyes are perhaps the most haunting detail. We don't fully understand what Opabinia saw. We don't know if all 5 eyes worked together, or independently, or whether some served a completely different function. What we do know is that this animal was watching the ancient ocean through a sensory system that evolution abandoned entirely. There is something deeply unsettling about that. A way of seeing the world that existed for millions of years, and then simply stopped. No descendants, no modern equivalent, just the fossil and the 5 dark impressions where the eyes used to be. But Opabinia was not a predator in the way we usually imagine. For that, we need to look at something considerably more powerful. Anomalocaris canadensis. The name translates, somewhat awkwardly, to abnormal shrimp, a name given before anyone understood what they were actually looking at. Early researchers found isolated parts of this animal and classified them as 3 completely separate species. The circular mouthplate was identified as a jellyfish. The frontal appendages were thought to be the tail of a shrimp. The full body wasn't recognized for what it was until the pieces were finally assembled. And when they were, the Cambrian Ocean got a lot more frightening. Anomalocaris was the apex predator of its world. At up to 1 meter in length, possibly longer based on fragmentary evidence, it dwarfed nearly everything else in the burgess-shale community. It had large, compound eyes containing thousands of lenses, giving it exceptional vision. It moved through the water using a series of overlapping lateral lobes, rippling like a living fan. And those frontal appendages, the ones mistaken for shrimp tails, were spiny, grasping structures used to seize prey and pull it toward that circular, pineapple-slice mouth. Some researchers believe Anomalocaris could crush the shells of trilobites. Others suggest its mouth may not have been strong enough for that, and that it targeted softer prey. The debate is ongoing. What is not debated is this. For millions of years, Anomalocaris was the largest animal on Earth. Full stop. In a world where most life was measured in millimeters, this creature was a meter of muscle, vision, and appetite, cutting through the water while everything else got out of the way. And yet, even the apex predator of the Cambrian had a rival in strangeness. Cambroraster falcatus was only formally described in 2019. Its nickname, almost immediately, became the Vader fossil, because its broad, horseshoe-shaped head shield bears an uncanny resemblance to the helmet of a certain cinematic villain. It was roughly the size of your hand, and it may have been a filter feeder, using raking appendages to sift through seafloor sediment for organic material. What makes Cambroraster so significant isn't its size or its predatory power. It's what its discovery revealed about how we read the burgess-shale itself. Researchers found Cambroraster in enormous numbers at certain sites, which tells us something remarkable, that this creature wasn't a rarity. It was abundant. It was part of a functioning, complex ecosystem, filling an ecological role, living and dying in vast communities, right alongside Anomalocaris and Opabinia and Hallucigenia. The burgess-shale isn't just a collection of bizarre outliers. It's a snapshot of an entire world, and most of that world we still haven't found. Here is the question that should keep you up at night. The burgess-shale preserves soft-bodied animals, creatures with no shells, no bones, no hard parts, with almost miraculous fidelity. That almost never happens. The conditions required for that kind of preservation are extraordinarily rare, which means that for every fossil site like the burgess-shale, there are thousands of ancient ecosystems that left no trace at all. Every creature we've discussed today survived the greatest lottery in natural history, the lottery of preservation. They made it into the rock. Their neighbors, their predators, their prey, most of them didn't. So what were we missing? What body plans? What eyes? What ways of moving through the world existed in those unpreserved seas and vanished without a single fossil to mark their passing? The burgess-shale gives us a window, but it also shows us very clearly how small that window is. We are looking at fragments of a world that was already ancient when the first fish appeared. And every answer we pull from the rock arrives with a new question attached. The shale is still being excavated. New species are still being named. Somewhere in the Canadian Rockies, in a layer of stone not yet split open, there is almost certainly something waiting. Something that will make Hallucigenia look straightforward by comparison. What do you think we'll find? If this kind of deep-time mystery is what you're here for, you're in the right place. Subscribing means you won't miss what comes next. And trust me, what comes next is stranger than you're expecting.